Now in this video, I'm just gonna basically focus on shortcuts to integral questions for multiple choice. Suppose you have a multiple choice question and you're asked to evaluate the integral. Now let's start with maybe suppose that you have a linear equation 1 over another linear equation. Now that you have these two linear equations, suppose that we are deriving with respect to x. The variable can change, but suppose we are deriving with respect to x. So that means that we're going to have a linear function over a linear function where we look at x. So suppose that the first linear equation was ax plus b, and suppose that the second equation was fx plus d. So suppose that we have this. So now that we have this, what I'm going to do is that I'm just going to make a u substitution. Let u equals fx plus d. So when I have that, I'm just going to solve for x here. Or before I solve for x, let me find du. If you derive this, you're just going to have 1, and you show that you're deriving with respect to u. And if you derive the right-hand side, you're just going to have f. And you have to show that you were deriving with respect to x. So that makes dx will be equals to du over f, if you look at that. Now then we can further solve for x in this one. So we're just going to have x. You're just going to subtract d, then you have u minus d, and then you divide by f. And that will be the value of x if you solve that here. Then you're just going to substitute that in. So if you substitute that in, that means this integral will just be the same as a, where you substitute u minus d over f, where there's x and you have b, and then you're going to have f into, now this one is just u over f. So that's what you're going to have. Excuse me on this one. So remember, fx plus d is u. So now that you have this, what you're going to do is like you're going to further simplify this. So what I'm going to do is I'm going to multiply both the numerator and the denominator by f. So I'm just going to have the integral of af to u minus d over f. That's, you multiply this term by f. You're going to multiply this term also by f. So you're just going to have bf. Now, you're going to divide by uf. Remember, I just multiplied everything with f. Then, now you have du over f. That means that this f will just multiply with this one, with this term here. It will just multiply with this term, so you'll have f squared there. So now you're going to like simplify further. So you're just going to have a. This f will cancel with this one, and then you'll just have au minus, with this negative sign here, multiply, and you multiply a with d, so you have ad, and then you're going to proceed, then you have bf right there, and then you divide by uf square. Now you're deriving with respect to u. So now you're going to break this into, you're going to separate this and write them in the form that you can be able to integrate directly. So I'm just going to separate each term now. So what I'm going to have is that I'm going to have a over f square. A over f squared, that's u will cancel with u on this term. Then you subtract, you have a negative sign, and then you have ad over f squared, and then you still have 1 over u on that. And then you'll have bf over f squared. Then this f will cancel a square here, and then you'll just have 1 over u like this. And now you show that you are deriving with respect to u. You show that you are deriving with respect to u. Now, the integral of a constant is just going to be that constant multiplied by u, and then you're going to subtract ad over f squared. The integral of 1 over u is just going to be ln the absolute value of u, and plus b over f multiplied by the integral of 1 over u will just be ln the absolute value of u. Then you're going to add a constant. Now, if you look at this, form, you can factor this by ln u. Now, you have a over f squared u minus ad over f square, I'm just gonna put the negative in front now, the negative in front, minus AD over f square, and then positive into negative is gonna be negative, so you have b over f, and then you factored by ln the absolute value of u, then you have your constant there. Okay, so now we're gonna continue. Then we can like simplify this, so you have a over f square u minus, now you have AD minus, since this is f squared and this is f, that means you're going to multiply this term with f, so you're just going to have bf, and then you divide by f squared. Now you multiply by ln the absolute value of u, then you add a constant there. So now you're going to substitute u back now, so you're going to have a over f squared into, now u, back to that, u is equals to fx plus d, so you have fx plus d, then you subtract AD minus BF over F square multiplied by ln the absolute value of Fx plus t. Then you add a constant there plus a constant. Now that we have this, we're gonna have a over f square multiplied by fx. This will just be f will just cancel the square, then you'll just have a over fx plus d multiplied by a over f squared. This is gonna be constant. It's gonna be constant, so it's accounted in this one. A constant plus a constant will just be a constant. So we don't need to take that into consideration. So we can neglect that. Then we'll have minus AD minus BF over f squared. Don't forget to open brackets on this one. Then you have ln the absolute value of fx plus d, then you add your constant there. So that's the shortest card if you keep in mind this formula. So what this formula tells you is that if you're integrating two linear functions, the quotient of two functions, remember you have the quotient rule for deriving. Now I'm just showing you a linear quotient rule for like for integration of linear functions. So this is only for like multiple choice questions. You don't remember, my formula is that the integral of ax plus b divided by fx plus d dx, this will be equals to a over fx minus ad, sorry, it's ad minus bf divided by f squared multiplied by ln the absolute value of fx plus d, then you add a constant. So how do you apply this? So basically what I'm saying is that if you have linear functions like this, suppose that you have 2x minus 4 divided by 3x plus 2 dx. Suppose you're looking for the integral of this and it's a multiple choice question. So what you're going to do, you're going to evaluate it like this. You're going to divide this 2, which is just 2 over 3. It doesn't simplify, so it's 2 over 3, then you just multiply with x. You just take the ratio of this, then you multiply with x. And then you're going to subtract, then you multiply 2 with 2. You just go like, it's just a cross. No? Yeah, it's just a cross. It's just, then you say 2 by 2, then you're going to have 4. And then you just do the same. You just put a negative and you do the same. So it's negative 4 multiplied by 3. So it's just a cross again. So it's negative 4 times 3. Negative 4 times 3, that's going to be minus 12. And negative into negative is going to be positive. But let me just write it as negative 12 so you don't get confused. And then you divide by this one. You only look at the gradient of the denominator, then you square it, which is just going to be 9. And then you multiply by ln the denominator. So you ln the absolute value of the denominator, just like this. Then you just add a constant, then you're done. Then you can like simplify that, so it's 2 over 3. It doesn't simplify this one. And then it's minus. Now, negative into negative is going to be positive, so you have 4 plus 12, which is 16. So you're just going to have 16 over 9 multiplied by ln the absolute value of 3x plus 2. Then you add a constant. So that's how you can like basically work that out. So it's basically simple, really, because it's not that big of a deal. It's not that complicated. So whenever you do multiple choice questions and it's two linear functions, keep in mind I said linear functions. It can be any linear function. Suppose that you have x plus 6 divided by 2x, let's just say minus 5 dx. So if you're integrating this, remember what I said? You just say, remember here is just 1. X is just the same as 1x. So you just take this ratio, which is just half, and you multiply with x. Then you're going to subtract, then you say this 1 times negative 5. That's going to be minus 5. Then you say negative, then you say 6 times this 2. It's positive 6 times 2, which is just going to be 12. And then you divide by this 1 square, which is 2 square, which is just going to be 4. And then you lean the denominator. Then that's just basically how you can like evaluate that. Then it's just a matter of like simplifying. Then you have half x minus, now you have minus 5 minus 12. Minus 5 minus 12, that's going to be what? That's going to be minus 17. And remember, you have a negative sign here, so negative and negative will be positive. So you'll have 17 over 4 ln the absolute value of 2x minus 5 plus a constant. So you do this on multiple choice questions. You can basically do any linear, as long as it's just a ratio of two linear functions, then yeah, you can work it out like that. So this is just a shortcut for like multiple choice questions. See if you can like try this one. 2x plus 7 divided by 9x plus 18 dx. See if you can like work this one out. Can you work it out? Okay, so what you're gonna do is you're gonna take this ratio 2 over 9, then you multiply with x, then you're gonna subtract, then you say 2 by positive 18, that's gonna be 36. Then you subtract positive 7 times 9, that's gonna be what's 7 times 9? That's 63. So you have something like this. Then you square 9. 9 squared, that's going to be 81. And then you lean the denominator. So lean the absolute value of the denominator. So just in this case, will just be 9x plus 18. Then you add a constant. Now from then, that means that you just have 2 over 9x minus, now 36 minus 63. Then notice that 63 is greater than 36, so we can neglect that. We can make this positive and just say 63 minus 36 because of this negative right here. So 63 minus 36. So notice that we can take can say 13 minus 6. 13 minus 6, that's what? That's going to be 7, and 5 minus 2. 5 minus 3, that's going to be equals to 2. Then you have 27 divided by 81. But notice that 27, that's 9 times 3, right? Which is just 3 to the third. Remember, 27 is just 3 to the third, and 81 is 3 to the fourth. Then you say lean the absolute value of 9x plus 18 plus a constant. Now, you're going to simplify this, so you have 2 over 9x plus 3 to the third divided by 3 to the fourth. You can just use the laws of exponents and say it's 3 to the 3 minus 4, so which is the same as 3 to the power minus 1, which is the same as 1 over 3. Then it's just lean 9x plus 18. Then you can just basically evaluate. That's just simple like that. So that's how you can like evaluate two linear the ratio, evaluate the integral of the ratio of two linear functions. So it's basically simple, and I hope you found this to be helpful. So basically, you can work it out like even further. You can further practice this technique so you can like be able to avoid mistakes when you work on multiple choice problems. Suppose that maybe we have the integral of x divided by 2x plus 6 dx. If we have this, that means that we can still apply it because x is a straight line. If you graph y equals x, it's a straight line. And if you graph 2x plus 6, it's still a straight line. So it applies. That formula applies. So I'm just going to do that. Keep in mind, x, this is the same as the integral of x plus 0 or x minus 0 divided by 2x plus 6 dx. I'm just doing that because I want you to like be able to analyze that it's still the same formula as that one I showed you. So how you evaluate that? You take this ratio. Which is just 1. This is just 1x, so you just have half. So you have half, then you multiply with x, and then you're gonna subtract. Then you just say this 1 multiplied by positive 6, which is just gonna be 6. Then you subtract positive 0. Sorry about that. It's just 0 multiplied by 2. So it's just going to be 0. And then you square this 2 here, which is just going to be 4. And then you have ln the absolute value of 2x plus 6. Then you have a constant. You add a constant there. So you have half x. Then 6 divided by 4 is 3 over 2. So you have minus 3 over 2 ln the absolute value of 2x plus 6 plus a constant. So you can basically do this for all linear ratios. You can integrate all linear ratios. So thanks for watching. Don't forget to share and subscribe. And if you're going to use this technique, please try to practice it so you get used to it, so you can be able to integrate uh, multiple choice questions pretty much fast. Suppose if it was linear ratios.